What? All right. So everyone, hope you guys got the chance to get the pizza, the free pizza that Daniel you're missing because you're sick. So sucks to be you. But everyone else joining online, thank you so much for joining, except for Daniel. Welcome to the 12th general body meeting of ACM at UC. If you probably heard me give the spiel 1,000 times, but please log in your attendance at acm@uc.org/c. Takes like 5 seconds to fill it up. It kind of helps us keep track of our meeting attendance as well as towards the end of the semester. We'll have elections which are closing up. So honestly, I think we have like 2 or 3 meetings left before the elections, and it just kind of helps us keep track of our eligible voting members. All the ACM meetings will be recorded, including this one, and uploaded to YouTube, which I haven't done in a while. So you'll probably see like 3 or 4 YouTube videos being uploaded back to back, including this one tomorrow. But again, like I said, if you aren't yet, fill out the attendance form. Our mission, the mission of ACM is to encourage professionalism among tech enthusiasts in a collaborative fashion by facilitating learning beyond the scope of classrooms to develop innovative and inclusive ideas. So we kind of want to bring you skills or learning that you generally would not have learned in classroom, and that's why today we have Spencer talking about not using variables and immutable states. That's what our mission is, and we've tried to stick to that as much as we can this whole year. But what is ACM at UC? ACM is the student chapter of Association of Computer Machinery, the way I like to say it. I've been made fun of this so far, but I like to say it's where all the cool CS kids hang out. And so it's a community of students built around common interest in computers, technology, and software. Although most of our majors are computer science, IT, IS, computer engineering, electrical engineering, we are open to all and every major. What do? We do events like socials, professionals, and technical events. Like today, we have a guest speaker at our general body meeting. We also do ICPC, which should be coming up soon. We had Revolution UC the past weekend, which is super fun. A lot of the organizers as well as attendees are in this room for Revolution UC. We also host socials and review sessions. So last semester, we hosted a review session for Python, since one of the ENET classes focuses a lot on Python, and this end of the semester, hopefully we can do a C++ review sessions. We also have a Slack community, a Discord community. We record our meeting minutes, and we also have office hours. Membership requirement, you only need to attend 2 meetings. That's it. You don't need to pay any ACM national fees. And if you do attend 2 meetings, that means you either can vote or run for exec in our end of year elections. And this meeting does count as one. So if you're here, all you have to do is attend the election meeting, and that will count as 2 meetings. Code of conduct. ACM at UC is dedicated to a harassment-free experience for everyone, and our anti-harassment policy can be found at acm@uc.org/conduct. But in general, just be cool, be nice to everyone, not that hard. Academic services, like I said, we provide review sessions and also office hours. ICPC, it's the regional meeting of programming competition, and it's essentially just lead code competition. So registration information will be announced soon. Revolution UC. We had Revolution UC over the past weekend. You've heard me talk about it in every single meeting this whole year, and we actually finally did it. So it is UC Student Run Hackathon. I think it was a great success. We have a great turnout and so many fun events within the hackathon itself. So be sure to look out for Revolution UC next year. Over here, you can see some pictures or like screenshots that we took during the event. And we also had some of our alumni join, as well as most people in the pictures are in this room itself. So say hi to them, and we also had some companies come in and present and send representatives in the event, which is super fun. Also, be sure to follow our socials to stay up to date with Revolution UC. Although you wouldn't see a whole lot for the next for a month or 2, especially because all our organizers are so tired, we've mentally checked out. But we do have a new TikTok, and we uploaded a good amount of TikToks during the hackathon itself. So do follow us on TikTok. It's amazing. I think we've made some great, funny content on TikTok. ACM at UC's community server. We also built the community server over the past 2 weeks. So a lot has happened since the last meeting. All thanks to Piyush. Piyush has been spending so many days in our server room itself. It's basically his baby at this point. So many times I just like to call Piyush or text Piyush and he'd be like, hey, sorry, I was in the server room working on the server. But he's been working really hard for it and we're preparing it for general body to use as well. And we also use it for our Minecraft event at Revolution UC. So it already is ready to use. We just want to prep some things up before we can make the full use of it for general body. Next, if you haven't yet, join our Slack. Great way to know about what ACM is up to, be it our general meetings, socials, or any other event that we're doing. And same goes for Discord. If you haven't yet, scan the QR code and join it. Discord is a little bit more informal, but you still get the same information that you would in either platforms. Other resources, you can check out all these resources as well as YouTube to stay up to date and either get these meeting minutes or recordings on those websites. Next, we'll have Spencer both come and talk about stop making variables, immutable state. So I'll let Spencer take over using his slides.
Awesome, thank you. Yeah. Hi everyone, good to see you all here today. Appreciate you coming. So today I'm going to tell you why you should stop using variables. Variables are a terrible thing. I'm sure you've taken intro to programming. They poison your brain. They tell you put variables in your code. Don't listen to them. Before we get to that though, actually I want to start out. I'll take a poll of the room. How many people here have heard about immutable state? Immutable state. Awesome, we got a couple people. A little bit. So for anyone that doesn't know, I'll go ahead and explain kind of some of the concepts behind it. So immutable state is essentially anything where you create a value and you assign it to a keyword in a language, and you never change that value. So for example, in JavaScript, if you write const a equals 2, a is now 2. That's immutable state. It will always be 2 no matter what happens. And the great thing about that is it makes it very easy to test things if things are not changing over time. For example, if I have, a times 2 and I want to test that and I want to make sure that a times 2 is 4, it will always be 4. No one's going to assign to my variable and change that and break everything. So that's a little bit of why it's important. But before I go deeper, talk about who I am. So I'm a software engineer at Amperity. We're a startup over in Seattle. I work remote, and we're creating the world's leading customer data platform. We do some amazing stuff with data to make that happen. We're able to take multiple data sources, and you can bring that data to us. And then we, on the fly, are able to take customer records that don't have a key to join them together. We use machine learning to actually join all of that, create a customer 360, and it's a really cool piece of tech that we get to work on. I'm an amateur at functional programming. I've been working for, I think like about a month now at Amperity. I just started this new job. And so I'm not quite a professional yet, but I do love functional programming. And that's one of the things that actually got me interested in Amperity because we use a fully functional stack. Our whole stack is Clojure. I'll try not to talk too much about Clojure during the talk today because it's very niche. But that means that we don't have anything, we don't have any objects, we don't have any of that stuff going on in our code, and we're able to pull off all this really cool tech without having mutable state. So it's a completely valid way to, in probably the preferred way to build your applications. I was the president of BGSU's ACM chapter, ACM. And there actually started our hackathon. I really like puns, and so I called it the Falcathon. So that's the name they're stuck with there now. And I'm an advocate of long walks in the woods. I think it's a really good time. Highly recommend if anyone wants to go for a hike sometime around here. I'm always down. Let's see here. What have I got next? Oh, talk a little bit about Amperity. I talked about the most interesting stuff about the tech. We serve loads of major brands, Starbucks, Alaska Airlines, Tapestry, Kroger, all of these wonderful companies, and we process all their data. We have these giant batch jobs that run in AWS. And AWS actually just became one of our major partners. I think one of their quotes was that Imperity should be treated as an extension of the AWS platform, is how much we use it. Like they make a lot of money off of us. I'll put it that way. But yes, that's some of what we do. If anyone is interested, wants to know more about it, if you think you'd be a great fit for Imperity and this really interests you, talk to me after the talk. But that's enough of that. I'll stop doing my spiel. Now you're all students, so I thought it'd be great to do a learning outcome. The learning outcome today is that you will understand state and how to manage it better. Now, can I get anyone to take a guess of what state is? Give me a definition, anyone.
Data about the application.
Yeah, exactly. You got it. Data about the application, and most importantly, data that changes about the application. So you get a new user, the state of your application has changed. You've got an extra user in that list. And fundamentally in programs, you do want things to change. Even though I'm going to talk about how you don't want things to change today, things do change in your program, and you need to account for that. I think it was one of the major functional programming languages is called Haskell. And I really I was listening to this talk by the guy that created it. And he's like, the biggest problem we've had to figure out with our language is how we get it to affect the outside world. Because they tried to make the most pure functional programming language. And then it became a really big problem. How do we get values out? Because if you run an operation in Haskell and your box gets really hot and then it cools off, you've learned nothing. So you do need to change things in the real world. Now, through the rest of the talk, I'm going to give a brief history of procedural programming and then some of the paradigms that came out of that. And I'm going to kind of compare and contrast as we go along. And I've got a brief interlude in the middle about a little more about functional programming, and that's kind of new to a lot of people. And I'm going to finish it off with a demo where I show you some code that I've made and how a program that does the exact same thing looks like with different approaches in JavaScript. So we'll start with the first bit, the procedural paradigm. So I'm sure you've all coded in at least C or assembly before. There are no objects. There's really not much to it. It's just one line, the next line, one after the other. You use goto in assembly, for example, to be able to jump and create logic flow. And the problem with coding procedurally is that when you do that, you're going to end up with a situation where your code is a mess. You've got gotos, you're leaping here and there. You have no idea how you got to one piece of code, and then you hit a breakpoint there. And it's just kind of terrible. And things are changing left and right. And you don't know why they're changing. And so this is a major problem early in programming because, you'd have code projects would be very successful if they were small, but then they'd start to get bigger and bigger, and these projects would fail. If you look at software projects or the history of software projects, and you look at all the projects that have failed, there's so many of them, and these failures are expensive. I'm talking like hundreds of millions of dollars that get poured into these projects, and they fail because they're not able to handle the complexity in them. So out of that came two paradigms. I think this was like around the 70s, 90s, that kind of period in computing, where you had all these procedural programs that were just not getting anywhere. So one approach was object-oriented programming. I'm not going to talk about object-oriented programming too much today because you all know what that is. You've used it before. You've probably taken C++, Java classes. It's object-oriented programming. And then you have functional programming, which I'm going to try to convince you all today is much, much better and will make your life a better life. Let's see here. Boop. So first, we need a metric to be able to determine which programming paradigm is better. Now, I'm going to say that simplicity should be our paradigm. When you're coding and you're going through the programming, you're trying to figure out how you should do something, the limit most of the time nowadays is not how fast your computer program can run, but how well you can understand it to make it do the right thing. And that's what limits almost 99% of programmers nowadays, unless you're like doing cool stuff like video game design, in which case speed is a very big issue. So simplicity, something that's simpler, will let you understand and reason about it better. So that's why it's a really good idea to have in mind when we're trying to figure out what should be the best programming paradigm. Now, I will like to preface, if I were more wise, I would say, oh, each paradigm has a use for its need and, you know, all that. But today I'm just going to argue that functional programming is better. So we'll forget about being wise. So let's look at a couple of the definitions here. We've got the first one, A, is really good. Having few parts or features, not complicated or elaborate. So one thing that is composed of very few pieces, it doesn't have any complexity. God, I'm gonna go on another tangent. Complexity, by the way, would be the opposite of simplicity, right? Now, what complexity is very specific, and especially within the Clojure community. The author of Clojure, Rich Hickey, has very strong opinions on this. If you want to dive into simplicity more, watch Simple Made Easy by Rich Hickey. But I'll give you the summary real quick. Complexity is when you have two pieces of logic or two things that are twisted together. So that's the literal definition of it. Complex comes actually from rope making and fibers, where a complex thread is when you take multiple fibers and you twist them together. Simple, on the other hand, getting back to this, is B, easy to understand, do, or carry out. And C, I think, is the most accurate for what we want, having or composed of only one thing. It only does one thing. So, like in your classes, you've heard the, well, which principle is it? The single responsibility principle, SRP. Hopefully you've heard about that. Maybe not. That's the idea, something should do one thing. But that's what we're getting at here. Cool. Any questions? I talked very quickly. Okay. Looking good. Now, back to what I mentioned about complexity. If something is complex, it had to have a way to get there. And so one verb you can use is to complex, to make complex. So variables complex state and time. Now, how do they do this? Let's get back to my example of A earlier. We said that const A equals 2. Now, what if we change it to var A equals 2? Well, now it's not a value, it's a variable, because it can change. And because it's a variable, Bob, we all hate Bob. I hope no one's Bob here. Bob comes along, and he's trying to do something else somewhere else in the application. He sets A to 4. Now, us as the programmer on our end, where we're making our part of the application, and we actually created A, we don't think A is going to change. And because of what Bob has done now, it will only be right 50% of the time, roughly, to know what it is. And because of that, that means that A now has time and state kind of intertwined, because the state changes over time. So those are two things that you've now twisted together and you've made more complex, which is not good. Because it becomes harder to reason about the application that you're building. And the more complex something becomes, and the harder it is to reason about it, then the more bugs you're going to write, the more time you're going to spend implementing things, the more things you're going to break, which is not good because that drives up software costs. Now, why is this an issue? State poisons all that it touches. I hope I'm not too dramatic. No, I think that's the right amount of sincerity. Objects become complex because of state. If you had an object that never changed, imagine how easy that would be to unit test, to write a test for it and say, this object should do this when this happens. Easy. Application logic equally becomes complex because things are changing, you don't know when they're going to change, and you get weird bugs because, a value changed when it wasn't supposed to change, and and now the whole application caught on fire. Boom, your black box is on fire. So that is not good. Now, a couple of common traits of functional programming languages are that, and I'm actually going to start on the right here with pure functions. No mutations, only data. This kind of ties back to the last slide. Actually, who all is here has heard of pure functions? Got two guys. Can I get an explanation?
Well, I remember, because I think we did this in C++ class. It's essentially just like whatever variable you have like in inputs or like in your parameters, those values don't change in pure function.
Exactly. Yeah, and because those values don't change, that means that every time you call a function with the same values, you're going to get the same output. And so if you can compose all of your application logic of pure functions, things become so easy to test because you don't have cases where things could be changing, while you're running the program. You always know that if you put, 2 into a squared function, it comes out 4. So easy to unit test. And I'll actually talk to this with a little bit of personal experience. At LCS, where I worked previously, also where Yasha and Daniel work, or I forget, you do work there?
I thought that I can't.
Oh, okay, awesome. Yeah, so at LCS, we use C#. LCS is a great company too, by the way. I'm just going to kind of, bash on their object-oriented programming. But back to that, so we use C#. C# is an object-oriented programming language. And I worked on the product that Daniel works on. We were on the same team. And our whole API stack is all objects all the way. You've got your providers, you've got your data access layer, you've got your business logic objects. And writing unit tests for that becomes nightmarish. Because you need to mock, and we have dependency injection too, which is, I'll say dependency injection is a great solution to a problem that object-oriented programming has created. But no, that's a tangent. I'm not going to go there. But yeah, so you've got all of these objects, and it becomes terribly hard to actually test anything and be sure that your program is going to do what you want it to do. And sometimes people just not write unit tests because it's difficult. Two other aspects of functional languages is first-class functions. So first-class functions, you can essentially pass a function into another function, or you can get a function out of a function. Now, I'll show you a great use of this in the object-oriented demo that I have. It was going to be so difficult to, well, not difficult, but it would have been so verbose to try to write it without using functional programming that I snuck a little bit in. But yeah, so that's first-class functions. We'll look at that. Then we have recursion. Recursion is super cool. You can essentially call your own function to be able to work through data. So I'm sure you've all seen a reduce function before. So you have, two things like sum, for example, is a reduce function if you sum a list, and it takes two variables and it does an operation, and then it calls itself in a way to then take the next two together, and then that summates the whole list together. That's how you can kind of think of recursion. It's a really powerful tool. And if anyone wants to learn more about that, I'll give you a link to a Berkeley class if I can find it. Just hit me up afterwards if you're curious about that. So cool, let's look at the demo. I'm really sorry to Daniel at home. I will not be able to show this on the recording, but I should be able to get in. Oh, wait, no, I can. Because wait, no, we didn't get the Teams meeting to work.
Maybe you can try something it once more and see if it works, but if it doesn't,
Yeah, let's take a crack at it. This might be a quick water break if anyone needs water. Pizza time. I was worried this was going to be way too short, but I go on so many tangents. But it's a good thing I didn't make it longer. Yeah, I forgot to get water. I'm sorry, babe. Let's see here. Okay, turn off my mic, turn off my video.
Probably will automatically ask you.
Okay. Wait, did Daniel leave? I don't see Daniel in here.
Daniel he bashed on LCS, guess that.
Oh wait, I think it's an Apple thing.
About
I think Chrome doesn't have permission to share. I can take care of it. Just take me a moment. Yeah. They told me to go to security and privacy.
I'm
Oh,
still
here we go. I
here.
have to click on camera. Okay, that should be allowed now.
Okay. Do you want me to try giving you permissions once?
Yeah. Oh no, I have permissions. Will it work? I don't think it did work. Yeah. Oh well.
Maybe you could try like a particular window, see if that works. Oh, but I guess you need to do the whole screen right for the demo.
Yeah.
Let's see.
Oh, maybe it's not camera. Maybe it's a separate screen sharing permission. Does anyone know Mac here?
I think there is a permission.
Yeah, if you want to help me, I'd appreciate a load. Yeah, so I'm in here.
Yeah, screen should be this one.
Oh, screen reporting. Oh, brilliant. No, I just need to add it then. I didn't say or
feel like
see
it
that.
should.
Yeah, sorry y'all. I've only used a Mac for 2 weeks now.
Maybe we can work Chrome.
Yeah. You see
Should be
it?
right there. You just passed it.
Oh, it's in
in
C?
Google. Yeah.
Oh, in Google Chrome. Yep, I was just looking for Chrome. Quit and reopen. That'll work. Yeah. So for the meanwhile, while I get this up and running again, any questions I can field?
How long have you been doing functions?
Oh, functional programming. I got interested in functional programming back in high school, actually. And then, college happened. I graduated a year early, so I kind of just ended up in a job working at LCS. And then randomly, a recruiter reached out to me from Amperity, and that's kind of what led to my transition into Amperity. Okay, I think we might be in action. Let's try this one more time. If not, I'll switch the screen over. Any other questions? No, okay.
I'm just trying to make sense of it in my head. And knows what this does. So
Oh, nice. Any specific?
no, I'm just making sure I get it. In the sense of, so the point of basically this talk is just there's a way to make sure that you can, instead of condensing code or trying to find a new language that makes code run faster, we can just change the way code works.
Yeah.
And the basic element, which is just variables, just either get rid of them instead using typo, which is I think someone has their mic
There we
open.
go. That was me. I had to mute. We're good now. That was ominous. But yeah, you're entirely right that the idea is that by using functional paradigms, both in JavaScript and, by actually using functional languages that force you to do it, you can write code that's more understandable, less error prone, and easier to unit test. Yeah, you're right on. Here we go for all the money. Ha! We did it. Look at that, everyone. How many programmers does it take? Yeah, now is there a way to make this full screen? Daniel, oh, he's gone.
Oh no, we had did a cameo.
Okay, well, if we can't make it full screen. Yeah, this is fine. Okay, so we're going to start out in here. I'm using Vim. If you use Emacs, you're wrong. Um, and here's the data that I've got today. It's very basic. We've got a collection of quotes from Michael Bobbins, who said, you know, beautiful quotes such as, "The way to hippo's heart is a dangerous path." Or "To where I woodpecker, I'd find me a tree." And then you have Abraham Lincoln, phone, question mark, question mark, question mark, and a couple of quotes from him. So let's hop into first. I'm going to look at the procedural code that I got right here. So you can see that we import that data, we console log out our, you know, quote.com most prolific writer. We've got a loop right here where we are grabbing the writer that's written the most quotes. So you can see we have a for loop. We loop through that, and then we also find how many likes that they've gotten. So pretty basic stuff. So if I run node procedural, you can see that Michael Bobbins has beat out Abraham Lincoln. He was pre-internet, so not very famous on quote.com. And Michael Bobbins had 26 likes. It's pretty good. Now, the only problem with that is you can imagine a code base, you know, 10 times the size, 20 times, 100 times the size. The longer that file of code gets, the harder this is going to be to understand. So today it's pretty easy to look at that. It's only, you know, maybe 30 lines of code, 20 lines of code, and understand it. But if you scale that up, it becomes a problem. So object-oriented programming says, okay, I know the problem to this. We need objects for all of these writers. We need to collect them into a guild of writers together and organize the code all into, you know, objects. Oh, before we do that though, I did want to point out a couple of things about the procedural code. So can anyone point out a couple of problems with this before we hop over to object-oriented? I should make that bigger. Is there a way to make it bigger? Oh, wait, I know how to make it bigger. But I'm going to have to go. Okay, give me a moment. I'm going to show you all something exciting and fun. Oh, wait, no, but I've got so many windows open. Like, look, yeah, I've got all of these windows open. I think we'll live with it. Can everyone read? Or can you not read?
Can you put like zoom in music though?
Oh, can you do that? That'd be really great. Control plus. Oh gosh, it made the icons bigger. Or actually, I know what I can do. There is something known as the terminal that maybe is there a way to make this bigger?
I think command plus.
Yeah, I tried command plus and it didn't. Oh wait. Oh, it's the command. Yeah. Oh, look at that. Wonderful. Okay, so I think I put this in proj, no more bars, perfect. Oh, that's so big. Yeah, so there we go. Oh, that's, what? Oh, swamp file. Let's just open it read only. We don't need to make any changes. Okay, perfect. So now that we're back here again after 3 minutes, does anyone want to point out any problems with this code? Any problems based on variables, maybe? Okay, I've got no bytes, so I'll just point them out. We've got side effects happening. So side effects are things that happen outside of the application or change things or do some kind of action. So logging out text to the terminal is a side effect. That is, you know, going outside of our application where we can't control anything. So we do a side effect at the top, and then we have a variable prolific writer, and then we loop through all of our writers using I as a variable, and we're changing that with the plus plus, and then we're assigning that whenever we find a bigger one. So this state is changing all of the time. And then we have down here, we do a very similar thing with our for loop over all of their quotes where we're incrementing likes. Now, this is a problem if someone in another part of the application also wants to use that global like variable that we've put right there, and they start doing something else with it. It could cause our program to stop working. We get a bug ticket. We waste 3 hours of our time trying to figure out what the heck happened. So that's why this is bad. Now, objects, the solution, the savior. Let's see here. Oop. Yeah, we'll do read only. Cool. So here we can see that we have done the same thing. We import our data, but we've now created these wonderful classes that are going to fix everything for us. We've got a guild of writers, where you can see in our constructor, we're creating all of our writers, and then we have all of this. You can see, you might notice something. The mutation's still there. It's just in the object now. What? How, it didn't fix anything. It didn't remove our state. Let's keep going. Now you can see we've got a function for show prolific writer, which, oh, well, this is actually not terrible. Here we have all of our side effects are in one function. That's better. If we keep going, we can see we have the writer class. It is the same thing though. We still have mutations here. They've just moved into the class. I'll admit, when I was coding this, for going from procedural to object-oriented, I actually didn't really write much code. I just copied and pasted code into a class namespace and, called it a day. So let's see here, going forward. And then we have the quote class, which is a lot simpler. It's just got a little bit of data in there. But this is another tangent unrelated to the points I'm making today. But look at all this boilerplate we had to create just to have a class. If you code in Clojure, you'll never have to do that. But that's a talk for another day. I'll come back next year. So yeah, you can see this. We've kind of moved everything around. We've organized the code, but we haven't reduced any of the complexity of these variables. So I'd like to show you. And how am I doing on time? Oh, we're doing good. We're doing good. Okay, cool. That'll leave time for questions. Coming to an end. Oh wait, no, I don't have a buffer for that. Oh, by the way, this plugin is called Telescope .nvim, and it is the best plugin ever if you use Vim. But yeah, let's see here. Let's do the great reveal. Oh, it's going to warn us that we have a swap file again. There we go. That's because we have Vim running in Alacrity too. So here's the functional bit. Now you'll notice something. I don't have to scroll anymore. Like I did for all the boilerplate when we did object-oriented programming. And even better than that, we don't have any random loops now where we're reassigning variables. We don't have any of that. All we do is the data comes in, and then we create all of our functions here. And I'll actually walk through these because they tell an interesting story. We come in, we go to show prolific writer. You can see here that it runs get prolific writer on data and then prints a report with that data. And this is unit testable. We can pass in a writer with, Bob Smith and the likes and everything, and we can verify that, it calls the other function with the correct the correct parameters. The only issue with that is that if we try to unit test that, then we have to do some weird stuff where we're making sure it called a function. But the rest of these are completely pure because you're not dealing with that print report function. So if we go to get total likes, you can see that what we're doing is, I mentioned earlier, reduce. We have a running total that starts with 0, and then we iterate over each quote. And then we add the number of likes into that total. So we reduce over that. So simple function, easy to test, easy to understand, no problem. Then we have get prolific writer. It goes ahead and it sorts by the length of the number of quotes. And then you just take the first one off the top there and you call it a day. And that's easy to test too. We pass a couple of writers in and we verify we get the right one. And that will never change. It's always input, output, pure functions, easy to test. And then print report up there, we have thrown all of our side effects into one function. You can easily see it. And isn't this more readable too than the procedural code? The procedural code, you had, the console logs were everywhere. Here we can see, oh, we print the report. This is what it prints out. Easy. And this is probably the easiest one to explain too. And I went into full detail. And you just kind of look at it and go, it does what it says it does. And you'll also notice, do we have a single variable right here? No. All the variables are gone, thrown into the waste bin. We've won. And that, my friends, is the beauty of functional programming. Thank you for coming to my TED Talk. So let's see here. I'll pop back into the slides and hop into a bit of Q&A we've got, we've got like 15 minutes. So, share the screen? Oh, stop sharing the screen. Yeah, so that it'll record properly. And I'll have to share it from there.
Yeah, I can just share it from here.
Yeah, we'll make a team effort. There we go. Okay, you should be able to share now.
Go screen. All right, I can actually.
Perfect. Awesome. So I've got some of the bullet points right here. But yeah, any questions?
So I saw you were using like sort and reduce functions to like avoid the for loops and everything.
Mm-hmm.
So internally within those functions, does like anything change in the logic of the code? Like if you were to include those as like part of your code in itself?
Yeah, so the thing with those is I'm sure under the hood they do use state. The thing though is that for all intents and purposes, you're worried about your application, and you don't have access to the internals there. So there's no way for you to affect that to break. And so it's kind of a non-issue. It's not a case where like I wash my hands of all of all mutation. But for the purpose of writing clean code, it's important that all of that happens at lower levels in libraries you're using, and it's pushed out of the reach of your, actual application logic. Good question. Let's see here. Any other questions? You're thinking about it. Oh, good.
Because we like data object oriented coding in classes like all the time. How can one like start learning and using functional coding?
That is a great question. I would start with, so it depends on what you're interested in. I would pick up a functional language and kind of try it out a little bit. There are a bunch of really great ones. Haskell is a brain like trip. Like it is made by people that work at universities. Clojure, on the other hand, is a lot more pragmatic. The only issue you're going to have there, if you want to like pick that up and play with it, is it is a Lisp. I can actually show some of that. Let's see here. Line run. Oh wait, nope, not there. That's going to run our application. Okay. That would have been very bad. You would have waited a while for that to compile. But yeah, no main namespace. Oh. That was the wrong command. Oh, I'm not sharing my screen. Oh. If I share it, it'll just take over. Okay. Should have thought about that. Maybe not. Oh, yeah, that's the problem. Perfect. Okay. So now that we're here, so I run line REPL. So I'll go ahead and show you a little bit of Clojure real quick since we got some time. But yeah, so for example, one of the really weird things is that it has prefix notation. So +1 equals 2. So one of the cool things about Clojure, and actually maybe next year if I come back for a talk again, I'll talk about Clojure, is that all the code is data. So there are these cool things called macros in Clojure, and what you can actually do is you can have a function that runs to modify the code that you've written. And so it takes in as an argument the code that you wrote, and then inside of there you can modify it to do cool stuff. So for example, if I want to call reduce plus, and then I pass it a list. I hope this will work because, yeah. So for example, what's happening here is, and this goes back to higher order functions, plus is a function that adds two things together. And reduce is actually not, well, I think it's a macro, because I think what it's doing here is it actually expands it out so that instead of this here, which you see, what a macro will do is it will take your code and it will make it 1 plus 2, 3, like that. And so it'll reduce it out, which is super cool. But that's kind of Clojure. This is kind of what it looks like. If you do want to get into it, I recommend For Clojure is a great set of exercises to kind of guide you through the learning steps. If you like books, Clojure for the Brave and True is really good. If you like videos, I'm sure there are good ones on YouTube, but I do not know much about those. Or you can always reach out to me if you want some more tutorials, or if you have a question, happy to answer them. Oh, speaking of which, if anyone wants to take down my email, I'm spwolf18@gmail.com. So feel free to reach out to me, especially if you're interested in working at Imperity. We're hiring like crazy. We were 150 people last year. We're 300 now. The goal is to be 600 by next year. We've got crazy fast growth right now. So.
How long has the company been around? Like you had all those partners and customers.
Yeah, that's a great question. I think we got founded in 2016. We got our first customer in 2018. And there was a little bit of a lull while we were building out the platform. But I think it was last year that we kind of jumped into high gear. You know, we kind of had the product in a really good place. We knew how to sell it. And ever since then, you know, the growth train has been kind of crazy. But it's super fun to be a part of. The people there are super wicked smart. So I'm learning a lot right now, which is really great. Yeah.
This is only because you told me this before, and I'm going to people like to know it. Where is it based and what's your work location like?
And what's what?
Where is the company based and what's your work balance like?
That's a great question. It's based in Seattle, Washington, and New York. Although they give you the option to work wherever you want. I chose remote, which is why I'm here in Ohio. And the work-life balance is really good. We have unlimited paid time off. So, and they encourage people to actually take that, because a lot of companies, you know, it's a good thing or a really bad thing. But it's really great. You know, if I want to go on a nice vacation, I can just, you know, come up with a plan for who's going to be doing what while I'm gone, and sayonara. Day to day, there's really no pressure to, you know, work overtime or anything. So good work-life balance, yeah.
So I have a couple of questions. What's the biggest project that you've worked on or you've seen that like fully uses a functional stack? You can point to and say like, hey, yeah, you can build complex applications using functional programming. You don't have to go for the Java or C#.
Yeah, I mean, really, I think you can build anything you want in functional programming. The only case where I don't think you'd be able to would be very high compute applications where you need to be working at the machine level and have assembly or C. But 99% of cases, especially applications, you can use Clojure. The biggest one I've worked on is Imperity. We have a full built front end that allows you to interact with the application. We're not just like, you know, a software as a service with an API. We've got a full front end application, all functional. We've got all of our backend fully functional. We ingest data daily using Clojure. We have machine learning running using Clojure. The only parts that we don't have built on Clojure are a couple of data science models, and that's mostly due to the fact that data scientists don't know Clojure. And so Python works well enough to allow them to do their job. Yeah.
You said the front end is built in functional. What language does that use?
Clojure. So that's a good question though. Clojure, so what you see right here is actually running on the Java virtual machine. Clojure is, as a language, is made to have a host language. And so actually from JVM Clojure, you can access all Java libraries, you can access anything, which makes it very easy to sneak into a project because you're like, oh, it's just a Java library, and you just sneak it into to wherever you want. But yeah, so that's the backend that we use. We run on the JVM for our work. Then with the front end, we use Clojure script. So it compiles using the Google Clojure compiler into JavaScript. But for all intents and purposes, it's Clojure. Although you can access Java libraries through interop, which is really nice, or JavaScript libraries. Yeah.
But your examples were in JavaScript, so do you also do like functional programming in JavaScript just as a hobby, or is that like?
I don't do any JavaScript anymore. At my last job, I was a TypeScript developer. But I've now washed my hands of JavaScript. I mainly used it here because it's good to illustrate the point, because you can demonstrate any paradigm in it. It's got functional stuff, it's got procedural, it's got objects. So yeah, but good question. Yeah, go ahead.
Do you like actively, since you use both the like coding JavaScript, like would you recommend like you actively trying to avoid object oriented and procedure for a more pure functional way, or just like adopt whatever you like at the moment?
Yeah, with JavaScript, I always tried to write more functionally. Back when I did TypeScript and JavaScript, same thing. But with my new job, there are no objects in Clojure, so I can't even be tempted. It's just you are writing functionally, which is really nice. And the neat thing about Clojure is it's not just another language. It's very opinionated to almost force you to write functionally and write functional code that's really good and readable, which is great.
This may be like a stupid one, but since you have like no classes or like you have no objects, but in the front end you still have like models at least to like organize complex structures.
Good question. So we have on the front and back end data. It's kind of like no, I think no is the right answer here. We just have data that comes in. We do have one of the like really fundamental types in Clojure is a map. So a map is something that can, let's see here. So if I wanted to get A out of this map, which has A is 2 and B is 4, then I could write something like that. And that's kind of how you access data. And the cool thing, so these weird colon letters that you can write, something like Emacs, that's a keyword in Clojure. So you can think of it kind of as a key to a map. And here you can see that we're accessing that map that has the data in it. So that's kind of how it's done. You can think of it kind of in terms of like JSON-like data structures. Is kind of how everything's organized, but there's no schema. You're not going to break anything by, throwing a random variable into a map. Yeah, the author of Clojure has argued that you don't need types. That's a very strong opinion that he holds, and probably one of his most controversial opinions. But I think really most of the time, the problem isn't that the developer has made an issue that a typing system can fix. Most of the time, the developer doesn't understand the code. And so it's more important to be able to make the code more understandable than have a typing system that's going to throw you an error. Yeah.
I think we have example.
One more question.
So majority of the industry right now, like using object-oriented programming, right?
Mm-hmm.
And I've heard about functional programming and I've read a lot of blogs about it. Where do you see the industry moving, like in the future, or like at least in like 5 years? Do you think more companies will adopt functional programming as a like primary paradigm?
Yeah, I think that in the year 2100, we're going to see a lot more functional programming. It's slow growth, but I think that in the end, it is inherently better. And so, over time, natural selection, eventually, hopefully, we'll see a transition more in that direction. But I think for the meantime, the most productive programmers, you're going to see them working in functional programming. And they're not productive because, functional programmers are smart or anything. That's not true. But they're more productive because functional programming is a good tool to think with and move quickly with. Yeah, that's a really good question. But yeah, 2100, I'm holding out hope.
Every single job I had, like everyone uses object-oriented.
It's, object-oriented everywhere, yeah. Cool.
Are there any questions in Microsoft?
Oh, good question. Let's see here. I don't want to go over time, but if Daniel's in here, asking a question. He's heard functional programming. The idea that functional programming is more difficult is a bit of a misnomer. Everyone's taught object-oriented programming, so it seems easier. But once you take the time to learn it, it's better. Yeah. And it's not intuitive because it's not the first thing you learned. Oh, Daniel's still here, crying face emoji. Okay. Well, thank you all so much. I've had a great time. It's been a pleasure. Yeah. Thank you.
Thank you so much for coming, Spencer, and having such a great talk. I for sure definitely learned a lot and try to make these changes at LCS, although I doubt they'll take any other suggestions.
Don't even bother. Oh, gosh.
All right. But again, thank you so much for a great speech, Spencer. It was nice having you here. Because it is almost 8. I'll try to close down real fast, but if you have any ideas for the talk, if you have any ideas for any of the meetings, come talk to me. Join our sibling organization, just IEEE, ACMW, UC Women in Tech, and ITSA. Most of the leaders of those orgs sitting right here. If you want to lead a talk or a workshop like this one, come talk to me. And you can see our full schedule at ACM at UC. And next meeting will be again actually, we won't have a meeting 2 weeks from now because that is spring break. So our next meeting will be a month from now. Just a heads up, do not show up. I guess if you do, you just see no one. So if you want to, you can, but there will be no meeting. Come join us at Discord, talk about your experiences, any fun projects that you've been working on, any classes, or any homework help. Thank you for coming. If you haven't yet, fill out the attendance form. For those who came late, it's at acm@uc.org/c. But that's it. Thank you so much for coming, you guys. See you in a month. Yeah, feel free to grab some pizza. Not you, Daniel. You cannot have pizza. I'm gonna end this meeting as well.